Proposition 45. To construct a parallelogram equal to a given rectilinear figure in a given rectilinear angle. Let ABCD be the given rectilinear figure and E the given rectilinear angle. So it is required to construct a parallelogram equal to the rectilinear figure ABCD in the given angle E. Let DB have been joined and let the parallelogram FH equal to the triangle ABD have been constructed in the angle HKF, which is equal to E by virtue of proposition 1.42. And let the parallelogram GM equal to the triangle DBC have been applied to the straight line GH in the angle GHM, which is equal to E from proposition 1.44. And since angle E is equal to each of angles HKF and GHM, angle HKF is thus also equal to GHM. Let KHG have been added to both. Thus, the sum of FKH and KHG is equal to the sum of KHG and GHM. But the sum of FKH and KHG is equal to two right angles from proposition 1.29. Thus, the sum of KHG and GHM is also equal to two right angles. So two straight lines, KH and HM, not lying on the same side, make adjacent angles which sum straight line GH at the point H on it, whose sum is equal to two right angles. Thus, KH is straight on to HM from proposition 1.14. And since the straight line HG falls across the parallels KM and FG, the alternate angles MHG and HGF are equal to one another from proposition 1.29. Now let HGL have been added to both. Thus the sum of MHG and HGL is equal to the sum of HGF and HGL. But the sum of MHG and HGL is equal to the two right angles from proposition 1.29. Thus, the sum of HGF and HGL is also equal to two right angles. Thus, FG is straight on to GL from proposition 1.14. And since FK is equal and parallel to AG from proposition 1.34, but also HG to ML from proposition 1.34, KF is thus also equal and parallel to ML from proposition 1.30. And the straight lines KM and FL join them. Thus, KM and FL are equal and parallel as well from proposition 1.33. Thus, KFLM is a parallelogram, and since triangle ABD is equal to parallelogram FH and DBC to GM, the whole rectilinear figure ABCD is thus equal to the whole parallelogram KFLM. Thus, the parallelogram KFLM equal to the given rectilinear figure ABCD has been constructed in the angle FKM, which is equal to the given angle E, which is the very thing it was required to do. Proposition 46. To describe a square on a given straight line. Let AB be the given straight line. So it is required to describe a square on the straight line AB. Let AC have been drawn at right angles to the straight line AB from the point A on it from proposition 1.11, and let AD have been made equal to AB from proposition 1.3. And let DE have been drawn through point D parallel to AB from proposition 1.31, and let BE have been drawn through point B parallel to AD from proposition 1.31. Thus, ADEB is a parallelogram. Therefore, AB is equal to DE and AD to BE from proposition 1.34. But AB is equal to AD, thus the four sides BA, AD, DE, and EB are equal to one another. Thus the parallelogram ADEB is equilateral, so I say that it is also right angled. For since the straight line AD falls across the parallels AB and DE, the sum of the angles BAD and ADE is equal to two right angles from proposition 1.29. But BAD is a right angle, thus ADE is also a right angle. And for parallelogramic figures, the opposite sides and angles are equal to one another from proposition 1.34. Thus, each of the opposite angles, ABE and BED, are also right angles. Thus ADEB is right angled, and it was also shown to be equilateral. Thus, ADEB is a square by definition 1.22. And it is described on the straight line AB, which is the very thing it was required to do.